Good morning, everyone. I'll be speaking about how to use cutting-edge health tech, but starting from a home setting. That's why I call it from home collection to preventive medicine for all. What we do is we look at the metabolome, use it for precision medicine, and then we digitize everyday blood samples, standard blood samples, and then make those addressable to our system. We all like cars. We would not drive a car without a dashboard, but we actually do not manage our health. We don't have a dashboard for health. This is what we are establishing right now. So we extract out of a blood sample, which we fully digitize, about 250 quantitative metabolomic markers. And then with our AI engine, we then turn this into health area, let's say, related statements. First, we started this as a preventive tool, covering diabetes, liver, kidney inflammation status, systemic inflammation, and cardiovascular, to be extended across further places. We have this implemented at first hospitals in Asia, actually, as a preventive medicine tool. And this is just the beginning, to be followed with deeper dives into disease-specific use cases. Now, what we do is we look at the metabolome as an information layer. We are all acquainted with the genomics, transcriptomics, and the proteomics approaches. They're all great, but either they are too far away from the actual real-time status of the individual, or they are too expensive. Our objective here is to have a test which is with a street price at around 100 euros, affordable enough that people can use it on a quarterly basis, and we basically capture those 250 metabolomic parameters, because they mirror the actual health status. And the metabolome is the execution layer of biology. This is where all those things are happening. So this information then can be extracted in different ways. So we have, let's say, use cases in preventive care. That's our commercial start, to be continued then in disease diagnostics. And most excitingly, I think, in treatment monitoring. Does a given treatment, for example, work on a given patient or not? Now, what happens is we first get a list of those metabolomic biomarkers. So there's just a short piece of this list. It's about 250 markers. And then we then process those lists, those concentrations with our proprietary AI engine. What's important here is not only the absolute concentration, those are also the mixing ratios between the different metabolomic markers, and then ultimately we get to an output in respect to the health status. Now, important is you can have the most fanciest technology if you cannot bring it to the people who have an issue. So addressing the first mile is very important. So on one end, we have optimized our system, obviously, for standard phlebotomy, because you find that everywhere in the world. So standard venous blood collection turning into serum. But we have also established home self-collection kits and SOPs, which work almost equally well. I say almost because they're always, you always have to pay a price, right? If something is a bit simpler, then you have perhaps a little bit of less markers, but because we have the profiles very well characterized, it works actually surprisingly well. We actually sent this to 300 German households earlier this year, and the feedback from the market was very positive, actually, in terms of the user experience. The workflow starts with the standard blood sample, ideally serum. It's being digitized in a machine called NMR. It's a strong magnetic field. It speaks to the physical properties of the metabolomic parameters, which then we upload onto our cloud. And we are a software company. Ultimately, we make the software available over the cloud to our commercial partners. We have quite a few commercial partners in Asia, for example, and then you get within minutes the automated output of the health reports. Now, this list of our partners, so to say, we have over the last couple of years now gathered about 270,000 physical human blood samples. They are stored in our facility. We have also fully digitized them. They're fully annotated with metadata. We don't publish. Our partners publish with our data. There's a better, cleaner way to do science. But basically, we have R&D work in the fields of oncology, neurology, and also, let's say diabetes and obesity. But we start with diabetes and obesity because, from a liability perspective, it's a better way to enter the market. And here, basically, you see the product hierarchy, the product architecture for the general health assessment. It's a combination of metabolites and lipid profile parameters. Now we are focusing first in preventive medicine, looking then into diabetes risk and diabetes treatment. This will be our plan for next year, especially where we will be launching an algorithm to assess insulin resistance and the risk for diabetes. At the same time, the very same panel can be used to also assess disease regression as a response to GLP-1 treatments. And then followed by liver use cases the year after. Because what's interesting is, so a few weeks ago, a physician called me and she told me what we are doing. She has heard about us at the conference, and she described it in a very nice way. She said, what you are missing out in the checkup you see here, because in the checkup you see typically when the metabolite parameter is in a normal range, you are happy, you go home, but you don't see that mesh is coming, for example, right? Now what we see is they can be still in range, but there are shifts in their ratios among each other. That means you can see the early changes, the early shifts in the metabolic pathways, which are indicative of the onset of non-communicable diseases, maybe diabetes, liver disease, or cardiovascular diseases. Now let's watch a movie which explains what we do.
Lifespin, the health data revolution. Lifespin only needs 0.5 milliliters of blood. Lifespin takes only one measurement for all tests. The NMR instrument is the interface between the physical and digital world. The patient's metabolomic information is being captured in one single scan using radio frequencies. Lifespin software engine extracts hundreds of clinical parameters from this data, generating the metabolomic digital twin of the patient. This digital twin is then compared to a vast database of human profiles. A personalized health compass is generated, showing your health status across numerous conditions. This data is summarized in a detailed health report, offering insights into prevention, diagnostics, and treatment of diseases. But Lifespin's vision for deep health extends far beyond the present, shaping the future of healthcare innovation. We are developing an AI foundation model that will have a deep understanding of NMR spectra, similar to how advanced language models comprehend text, and specifically trained transformer models will analyze all possible health conditions simultaneously, forming an omni-intelligent health software. Lifespin empowers you with detailed, actionable insights. Complex health data is transformed into accessible, affordable, personalized health information. Lifespin enabling.
Can always see how it works. And so basically, we have this as a software as a service model. So partners they digitize the blood samples. They're actually hospitals with personalized medicine teams, groups. They have those equipments. Then they send us those raw data. We send back the personal health reports. And then there are obviously great opportunities in the software as a service system. What's important is to emphasize is that we enable third-party labs. So we are right now speaking with major lab chains actually in Asia, especially in India. There are many exciting things going on because we enable them locally that they can use our software on their own platforms without any shipping challenges. So basically it's a plug-and-play platform which can scale over the cloud. Obviously, we are looking at a huge market with, and then with, let's say, with software as a service, it's a quite exciting business outlook. What our vision is, our North Star is basically to expand our software platform that it can recognize the most common health areas and can basically annotate the metabolites and the metabolic parameters accordingly. Now, what we have done actually earlier this year is we also invited just average people from the street to let's say visit us and to provide blood samples, and we gave them our reports in return was part of our market study. So basically within 4 hours we got about more than 70 people coming in, basically through all layers of young, old, and so on. And this was super exciting because it shows basically how the market responds to the type of reports we are generating. So that's in a nutshell, it's like what we have. We are fundraising, obviously. You can find me here. Thank you very much.